Hello, this is Miss Posa. So we are going to be going over all of the prerequisites in these videos. So first we're going to start off with prerequisite 1, algebraic manipulation of linear functions. So if you guys were in class, we saw a bit of these questions. The first one specifically, we were talking about our slope-intercept form, our point-slope form, and then our standard form. So what I like to do is we're going to start with point slope form. So point slope form looks like this. Y minus y1 equals m times x minus x1. So that's what point slope form is. And so when we're looking at the question and what the question's asking, our question is asking that as a line passes through 7, 4, and 3, negative 4, find an equation for the line in all three forms. So we already have our 2 points, 7, 4, and 3, 4. 3, negative 4. So let's start by finding our m. So our m stands for slope. And remember, to find our slope is our y values, so y2 minus y1 over our x values, x2 minus x1. So our y2 is negative 4, and our y1 is positive 4. Over our x2, which is 3, and our x1, which is 7. So we get negative 4 minus 4, which is negative 8, all over 3 minus 7, or negative 4. Negative 8 divided by negative 4, well, a negative over a negative is just positive, and 8 divided by 4 is 2. So we get positive 2 as our slope. Now, we have our slope, but let's try to put in, now we have our slope, which we said was 2, and then we still have our y values. So let's pick our y1, we said was 4. So we write y minus 4 is equal to 2 times, and in parentheses, x minus our x1 value, which we said is 7. So x minus 7. So that's our equation in point slope form. We can also write it with our other y value. So instead of y minus 4, we can say y minus negative 4. And remember, minus negative becomes positive. And that's equal to our same slope, which is 2, and then our x minus, and instead of our 7, we have our 3 up there. So we have x minus 3. Both of these are correct. So that's our point slope form. Now, let's go back to our slope-intercept form. If you remember, our equation for slope-intercept is y is equal to mx plus b. Well, from our point slope form, we have our m as 2. So let's write it in our equation. M is 2. So now we have our y values, which we have as our 2 points. We have our y value either as 4 or negative 4. And then we also have our x value, either as 3 or 7. But what we don't have is our b. So we're going to look for our b. And how we do that is we take one of our points. So let's take our second point, 3, negative 4. And we start with our y, which is negative 4. And we set that equal to our slope, which is m, times the x coordinate, which is 3, plus b. And then we solve for b. So we do 2 times 3, which is 6. And then to get b alone, we subtract 6 from both sides. We get our b is equal to negative 10. So now that we have that, we can finish our slope-intercept form. And we're left with y is equal to m, which is 2, x plus b, which we said our b is negative 10. So that's our slope-intercept form. So quickly looking at the difference between slope-intercept and point slope. Slope-intercept is in the title, slope. So we need our slope, which we have is our 2. And then the intercept means our y-intercept. So our y-intercept in this is going to be negative 10. That's where our line crosses the y-axis. That's why it's called intercept. For our point slope form, what we need is exactly in the title again, point and a slope. So the point that we used, we can either use the one that we had originally, which was -3, -4, or 7, 4. And then when we have our point and we need to find our slope, which we found over here. The last part is standard form. So we write standard form like this. AX plus BY is equal to C. And it looks a little different from the other two, but it's quite easy to solve. So what I like to do is we take our equation that we got from our slope-intercept, y equals 2x minus 10. And let's just write that over here. Y is equal to 2x minus 10. So to write it in the format of ax plus by equals c, we need our x values and our y values to be on one side, and then our c to be on the other. So to get that, we're just going to subtract our 2x from both sides. So then we're left with, on the left side, y minus 2x is equal to -10. And then we're left with our ax, which is -2x, our by, which is just y, is equal to -10, which is our c. So that's our standard form. So that's what our three forms look like for question number 1. Now, question number 2 is asking us to graph each of the lines. So the way I like to graph is, let's start with A. So when I graph, what I start off with is our intercept, our -2. So we know that -2 is where our y-intercept is. And we know that because if we set our x value equal to 0, that's where we get our y. So let's try that on the side. So we're solving for y when our x value is 0. And so when that happens, this part cancels out to just 0, because 0 minus anything is 0, and we're left with y is equal to -2. So before we graph anything, we always need to make our coordinate plane. And when we draw it, remember we have to draw arrows to show that it's going on infinitely. And then we also want to label our x and our y axis. Now, what we have over here, our y is equal to -2 when our x is 0. We can also write it as a coordinate like this. So when we graph it, we start off at 0, and we go down 2. So we're here. In each of these grid lines is just 1. You can label it, or you can choose not to. I'm going to choose not to for this, but you can do whatever you would like. So now let's pick another point. Let's try to find our y coordinate when our x is 3. So to do that, let's just multiply out and solve. So y is equal to 2 times 3 over 3. Well, if we do 2 times 3 over 3, since we have a 3 in the numerator and in the denominator, that cancels out. And we're left with y is equal to 2 minus 2, or y equals 0. So now we have the point 3, 0. And we found our x-intercept. When our y is 0, our x is 1, 2, 3 right here. So that's our second coordinate point there. Now, we can find more points if we would like, but since we found 2, we can just connect our line. So we just connect our 2 points, and then we can see the trend, and that's going to be how our line looks like. So another trick is to make sure that it's accurate. We count the slope. Our slope is rise over run. So we go up 1, up 2 is our rise, and then 1, 2, 3, that's our run. So we're going to keep doing that for each of our points to create our line. So we go up 1, 2 over 3, 1, 2, 3. Up 2, 1, 2 over 1, 2, 3 over here. And then since we're done, let's try to go down. So instead of going up 2 over to the right 3, we're going to do the opposite because we're going negative down. So down 2 over 3. 1, 2, 3 to our next point. Down 2, 1, 2 over 3, 1, 2, 3 to here. So now we have a large range of points. So let's connect them. So once we connect our points, we just want to extend in both directions because remember our coordinate plane is in infinitely many directions. And this is our line in blue. So that's the sketch of our line. And remember, rise over run is our slope. And our rise over run in this equation we said was 2 over 3. And as we can see over here, it matches up in our equation. So now let's try B. B, we're going to do the same format, but since I explained it a bit longer that way, we're just going to do it quicker, since you should all know how to do it by now. So remember, our first step is to create our coordinate plane if it's not already given. Make sure that you label our axes and draw arrows on both sides. Our y-intercept is 1, so when our x is 0, our y is 1. Then we're going to find another point. We can either find a point, or since we know our slope is negative 3, let's try solving it with just our slope. So negative 3 is our slope. And remember, our slope is rise over run. So our rise is negative 3, and our run, since it's not over anything, our run is just 1. Because, as we can see, negative 3 over 1 is still equal to just negative 3. So our slope is negative 3, so we go down 3, 1, 2, 3, and then over 1. Then we go down 1, 2, 3, over 1. That's our slope. If we want to go up 1, 2, 3, then instead of going right 1, we have to go left 1 because we're going in the negative direction. 1, 2, 3, over 1 in the negative direction. And then now what we're going to do is connect our lines, our points to make a line. So now we connect our points, and then we just extend it in both directions for our line. So that's the first page of our prerequisites. Let's go on to the second page. So now we're going to do some more sketching. So we just did 2 examples, so we can quickly go through these next 2. So we are going to start by drawing our coordinate plane and extending our axes and labeling them. And since this is in a bit of a different format, it might take a little extra step to solve this, but it's not difficult. It just looks a little different. So how I like to do this is we start with our x-intercept. So remember, for our x-intercept always occurs when our y is equal to 0. So we take our equation and we set our y equal to 0 and solve for x. So our x is 5 when our y is 0. So we have the first point, 1, 2, 3, 4, 5, 0. That's our first point. To get our second point, let's do our y-intercept. So our y-intercept is always when x equals 0. So we set our x equal to 0 and solve for y. And remember, when we are dividing by a negative, we have to include that in our answer. So we get when our x is 0, our y is negative 2. So let's draw our point on our graph. So now that we have these 2 points, we can just connect them and then extend our line in both directions. So that's our equation of our first line. Now let's do it for point B. So again, what I like to do is start with one of our intercepts. So let's do y-intercept. So our y-intercept is when our x is 0. So let's solve for our points. So when x is 0, we have 4 times 0 plus 3y is equal to negative 24. Our zeros cancel out. We're left with 3y is equal to negative 24. Or our y value is equal to negative 8. For our x value, we do our x-intercept. That means our y's are equal to 0. So we're solving for x. So when we divide both sides by negative 4, we're left with our x as positive 6. So when our y is 0, our x is 6, and when our x is 0, our y is negative 8. So now, we started with finding our points first, and then we draw our coordinate plane. And that's okay, as long as we make sure we label all of our arrows and label our x and our y's. So now let's plot each of our points. Let's start with our x-intercept. 1, 2, 3, 4, 5, 6, 0. That's our first point. And then let's do our y-intercept. Negative 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we just connect our dots and make sure we extend in both directions. So that is what our 4 sketches of our lines look like. Okay, so now let's move on to question number 4. Question 4 says that a recording studio charges a base fee for use of their facility plus a constant fee per hour of use. The table compares the number of hours the studio is used with the total cost C for the use of the studio. Use the table to answer each of the questions below. So what I like to do before I even start working on the question is just highlighting things that are important, or I think that are important. So it says that it charges a base fee. So it charges you money before you even use the studio. And then also a constant fee per hour of use. And whenever we see that word per, the word per is very important because it will tell us, it tells us units, it tells us what we need to divide by typically. And you'll see when we start to answer the questions more what that means. And then we also want to highlight, so it says hours that the studio is used. So we know that that's going to be one of our units, and then the cost in C. And as we can see, the cost is in C over here, and then our hours are over here. So we know, we know that that's going to be important. So the first question says, what is the fee charged per hour for use of the studio? We're seeing that word per again. So what we're trying to figure out is the cost per hour. So typically when we think of per hour, we're going to think of slope, miles per hour, minutes per mile, things like that. So in this case, the fee charged per hour. So the fee per hour. So what I like to do when I try to think of how we do that is let's look at our units. So it's the fee per hour. And when I think of the word per is division. So that's where we get fee on the top, per in the middle, hour on the bottom. So we don't have the fee, but we do have the cost per hour. So in our equation, right, we have cost over here. So this looks a lot like slope. Remember our y2 minus y1 over x2 minus x1? That's what we're going to be doing here. So this becomes, we can choose any of our y values, but I'm just going to choose these ones over here to make it a bit easier. So let's do 600 minus 450 all over 4 minus 2. So 600 minus 450 becomes 150, and 4 minus 2 is just 2. And if you can hear my dogs barking, I apologize. So 150 divided by 2 is 75. And remember, the question says fee charged per hour. It's asking for our units. So it is $75 per hour. Or we write the dollar sign up here, $75 per hour. That is our answer for what is the fee charged. This number is going to be important later, and you'll see in question C. So what is the base fee? The base fee for the rental of the studio. So we found the charge per hour, but remember in the question, it says that the recording studio charges a base fee. So the base fee is going to be our y-intercept. So how we figure out our base fee is we take our fee that we found, our $75 per hour. So we have $75 per hour. And then if we look over here, for 2 hours, the cost was $450. So with our base fee, let's take our 2 hours that we did and multiply it by 75. And when we do that, we get 150. And when we did that, what we found is the cost per 2 hours, which is $150. But remember, the total charged was $450. So let's subtract our 150 from 450 to find the base fee, which is 300. And again, this is our y-intercept. So our base fee is $300. And now I keep saying y-intercept, and it's going to be important right here in C, because it says write a linear equation. So I said that our y-intercept is $300. So in our format, y equals mx plus b, our b is going to be $300. So we can write that over here, 300. Our y, so we write y is equal to m. Remember I said over here, this is important, our $75 per hour, that's our slope. That is the thing that will be multiplied by. So that's 75 times x. So our equation isn't completely done yet. We have all of the important information in our equation. However, our units are h and c. So instead of x and y, we need to change it to c is equal to 75h plus 300. The cost is equal to 75 times hours plus 300, and that's our equation. So the last question says to identify the domain and the range for the function. So the domain, remember, domain down, like I said in class, domain down, that's going to be in our coordinate plane down our x-axis. So our domain is our x values, or in this case, it is our h values. So can we have negative hours in a problem? In this problem specifically, can we have negative hours for that we use the studio for? We can't. So when we write our hours, it always has to be greater than 0. It cannot be equal to 0. We can't have negative time and we can't have 0 time. For our range, remember our range are y values. And our y values here are actually going to be labeled as C. So remember, C is the cost. So if we look at it back at our equation, we can't have 0 hours. So if our h is 0, our C is equal to 300. So that means that our C, or our cost, always has to be greater than 300, because we can't have it to be less than or equal to 300 when we have 0 hours. If, for example, the person uses the studio for 30 seconds, then the price of the session would be $300 plus 75 times 30 seconds. So it would not be worth it to use it for 30 seconds. You would want to use it for a lot more time. But that's where we get our greater than 300. It's not equal to 300. Okay, so now let's move on to the last page. We have Jaden competing in a race. He runs at a constant pace from start to finish. So the key is the word constant pace. Since he's running at a constant pace, that means that it's going to be linear. Because the slope, when we're talking about the constant pace, we're actually going to be talking about the slope. So, since he's running at a constant pace from start to finish, the distance remaining in the race as a function of time is shown in the graph. Use the graph to answer the following questions. So, it says that the time is in minutes and the distance is in miles. So, as we can see over here, miles is in the y-axis and the time in minutes is in the x-axis. So, the question down here is asking, how long did it take Jaden to reach the finish line? In other words, what is the y-intercept? Since we're looking at time, when y is 0, okay, so I meant to say what is the x-intercept because our y is 0. So when our y is 0, what is our x-intercept? Well, it's over here at 80. And 80 what? Our units are minutes, so 80 minutes. What is our distance? So what is the distance of the race? Well, when we're talking about that, that's actually going to be our y-intercept. So what is our y-intercept when x equals 0? Well, when x is 0, our y is 10. And 10 what? 10 miles. So when the 0 minutes have passed, then we have 10 miles remaining. So that's how we know how long the race is. So now let's write a linear equation to model this situation. So let's start with the easiest thing we can find on our graph, which is our y-intercept. So our y-intercept, or our b, is when x is 0. And remember how we said over here, our x is 0 at 10. So our b is 10. So now we're trying to find our m in our equation. So to find m, it's a little bit more work. We just have to find the slope. So let's take our 2 points we know, 0, 10, which is this point over here, and then our 80, 0, which is the other point. And let's find our slope with that. So remember our slope is y2 minus y1 all over x2 minus x1. So our y2 is 0 and our y1 is 10. Our x2 is 80 and our y1 is 0. So then we get negative 10 over 80 or negative 1 over 8. So then that makes out the line of our equation in y equals mx plus b form. Y is equal to negative 1 over 8 times x plus 10. And so we know this is correct because our slope is negative and we see that this line is decreasing. Because as the x values increase, the y values are decreasing. So this is the equation of our line. So now we're doing domain and range again. Remember, domain is our x values and our range is our y values. So our x values are the minutes and our y values are the miles. So, trying to change colors. So, our domain is from the range 0 to 80. That's how many minutes it takes. We can write this in the form 0 is less than or equal to x, which is less than or equal to 80. And we're writing less than or equal to because we can have 0 minutes. The race doesn't start at 0. The race starts at 0, so we can include 0, and then it goes up until 80 minutes, including 80 minutes. For our range, our y, it's from 0 miles to 10 miles. We start at 0 miles, so that's why we can say less than or equal to. And then we end at 10 miles, and that's why it's less than or equal to. So that's question 5. Okay, so this is just prerequisite 1. I'm going to make another video for the rest of them because this video is getting quite long. But I will link it and you will see the video in the YouTube saved video list on the right of the videos. So I'll see you guys in part 2.